Hello, hello, hello. Welcome to the Fundamentals of Programming. Today we're going to be talking about Boolean and comparison operators. Now, I'm sure with those 4 words you have almost fallen asleep, but Boolean and comparison operators are extremely important, and they actually, as you will find out, are really, really useful. So let's go ahead and ask ourselves the question, why are these useful? Well, they form the foundation of creating programs that can make logic-based decisions. So if you think about a house or a structure, at the foundation you're going to have something very solid. So Boolean and comparison operators are something that's very solid, and they're logic-based. So these are the logic fundamentals that we're going to be able to build our programs off of. So things like if and elif statements would be what we're using, where we would use Boolean and comparison operators, as well as things like while loops and for loops. So all of these are going to be using Boolean and comparison operators in order to function. So they're really, really, really useful. And they're actually, well, very logical as well. So they're not super complicated. They're pretty intuitive. I mean, really any reactive program is going to need to use either a Boolean or a comparison operator. And let's take a look at a couple of examples and we'll see what that means. But first, let's familiarize ourselves with the comparison operators. And just to state what they are, a comparison operator compares 2 values, and it results in a single true or false value, which we know is a Boolean value. So there's 6 operators that are commonly used. That would be equal to, which is double equal sign. So obviously for this example it says 2 equals 3, which as we know is false because 2 does not equal 3. Then there's not equal to, which checks whether these 2 things are not equal. There's the less than, greater than, and less than or equal to or greater than or equal to comparison operators. So let's go ahead and go to our programming IDE here, and let's take a look at some examples. Alright, so let's say we had 2 variables. Let's say that we had a variable named x, which we'll say is 10, and a variable y, which is going to be 20. Now we can perform a number of logical tests or comparison operators to see, compare these 2 values. So if we say print x equals y, so this is going to check whether x is equal to y, and if it is false, it should print false. If it is true, it should print true. Well, we know 10 and 20 are not equal, so this should print true. Or false, excuse me. Obviously 10 and 20 are not equal. So, but if I instead switched it for an exclamation point instead of the double equal sign, this is going to check whether they are not equal. So 10 and 20 are not equal, so we should get true in this case, which we do. So again, there's the double equals, which is not to be confused with the single equal sign, which is the assignment operator. This is the equal to comparison operator, and it checks whether 2 things are equal. Now I could have just gone and hard-coded these values in here, but I wanted to show you that you can compare not just values, but also variables as well. So let's go ahead and see. Let's do another test. Let's see less than. Is x less than y? Should be true, and it is, because 10 is less than 20. What about is x greater than y? Well, let's see, it should be false because 10 is not greater than 20, and it is. What if we do greater than or equal to? Obviously, these are going to be the same. If we said 1 and 1, let's say y equals 1 and x equals 1. If we do less than or equal to, this should print true. But if we take out the equal sign, this should print false because they are equal. So you got to be careful about your bounds here, because if you are not aware of whether you want it to be less than or equal to, you might run into some issues with your code. So really, those are the pretty basic comparison operators. Nothing too complicated. The main thing to remember is that when you use a comparison operator, the output will always be a true or false value. Okay, so that's a Boolean value. It results in a Boolean data type. So you can use that Boolean data type if you so wish. Like if I were to say test equals x greater than y, and then say print test, it should print out the Boolean value of that test, right? So I can actually store this Boolean value if I so choose. So let's go ahead and go take a look at some of the Boolean operators, not just comparison operators. Let's look at Boolean operators. So if we take a look here, let's go ahead and see. So Boolean operators, they function the same way that logic gates do. So you provide two inputs, true and false, or a 1 and a 0, and it combines, it allows us to get an output based off of those things. So if we think about logic gates, there was the AND gate, which needed both inputs to be 1 or true in order for the output to be true, or 1 in this case. Then there would be the OR gate, which would be either A or B would need to be a true or false value, and then the NOT gate, which just inverts its input. So let's go ahead and go back to our, let's go back to the replet here, and let's go ahead and look at some examples for that. So if we take a look here, let's say that x equals, well, let's see here. So if we were just doing the operators here, so if we said test equals true, and you need to capitalize the T here, or otherwise it's not going to be a Boolean value, true and false, this should print false, because in order for an AND gate to be true, both of its values that it's comparing must be true. So if I do this, it'll print false. But if I switch this to true, it will print true. So that's the AND gate, right? Both A and B, if this is A and this is B, need to be true in order for the operator to be true. So that is the AND gate. If I were to do false and false, obviously this will result in false because they are both false. So if we did instead an OR gate, let's say false or false. So with the OR gate, what's going to happen is you either have for A and B, one of A and B must be true in order for the test to be true. So if I did false and false, it will be false. If I do false or true, it will be true. If I do true or true, it will also be true. So as long as one of them is true, then the output will be true as well. And then finally we have the NOT operator, which just inverts the Boolean value. So not true, test is going to be false. If I say not false, it's going to invert it and make it not false. So you're probably thinking, okay, cool, that's fancy, but what's the use? Now that is a really good question. Let's go ahead and say that we have three variables. Let's say that we have a variable called age, let's say it's 14, and let's say height equals 60. What you can do with this is we could create a comparison operator here. So we could use both comparison operators and Boolean operators. So I'm going to comment that here. So use both comparison operators and Boolean operators together to create logical statements. Now, let's go ahead and test this out. So if I say age is less than, or let's say greater than 18, and height is greater than 72, then I can save this value. Let's say that this is a ride test, like maybe I was testing a ride right here to see if they were old enough and they were tall enough. So then I can go ahead and print ride test. If it is false, I know that they are not tall enough or old enough. So if I hit run, it's going to be false. Now, if I were to change these variables to be 72, let's say 73, so it would be greater than the required height, right? 73 is greater than 72, therefore it will be higher. This would be a true value, but still this will be false. So if it was false and true, we know that that should still print false. However, if I said or, now it will print true because one of these values is true. And if that's a little confusing, let's go ahead and take a break from the actual programming aspect of it, and let's go look at a breakdown of that actual logical statement. So we can see how things are broken down from true and true for these comparison operators to the actual result. So let's take a break from this for a second. All right, so let's take a look at this example. So age is 14 and height is 73. So we were checking if 14 is greater than 18, or age is greater than 18, and height is greater than 72. So these both need to be true in order for the ride test to be true. So if we break this down, the way that it works is that the comparison operators are going to be broken down first. So what's going to happen is 14 is not greater than 18, so we will get a false here, and 73 is greater than 72, so we will get a true there. Then we're going to do the Boolean comparison, or Boolean operator. So false and true both have to be true in order for the AND Boolean operator to be true. So we get a false result. So again, the order is you evaluate the comparison operators first, then you evaluate the Boolean operators after all comparison operators have been evaluated. So that's how you use those together. They're very powerful together, and when we look at if and else and elif and while loops and for loops and all sorts of different flow control structures, we will be using these extensively. So it's important you kind of play around with these and understand them. So to summarize what we were talking about today, the first thing we talked about is that Boolean and comparison operators are used to logically test conditions or statements. Remember, they are the foundation of creating a logic-based program that can react to things. So they're very important to know. The next thing we talked about were the 6 types of comparison operators. Again, if I were to list those out, they are equal to, not equal to, greater than, less than or equal to, and greater than or equal to. They're pretty logical, and so you probably already know those just through math and through general life skills, I think. Then there are the 3 types of Boolean operators, and remember, those are they work the same way that a logic gate does. So with an AND Boolean operator, both of the inputs, or both of the things that you're comparing, must be true in order for the output to be true. Then there's the OR Boolean operator, which requires just one of the comparative values to be true in order for the output to be true. And then the NOT Boolean operator, which just inverts its input. So if you say not true, well, it's going to be false. If you say not false, it's going to be true. It's just switching those. So yeah, that's pretty much it, except for the fact that we showed an example of a Boolean and comparison operators used together, which is we're going to be doing that frequently, and you will get very used to doing that. And we broke that down and saw how those work together. So, all right, happy programming. Next video should be covering if, elif, and else statements, which will allow us to finally do something, make our program do something and not just print something. So that's going to be a fun video and should open up a lot of doors.